that we can use. Well, we can use ML5, we can use Amazon, we can use Google Cloud, we can use Keras, we can use TensorFlow. So there are a couple of tools that we can use there. And we can use the demo right now. So what we're going to be using here is a pre-trained model that we're going to be loading in our machine, in our browser, just to try to identify some objects in the room. So for example, here we have that we have a person there, and it's identifying the couch also. Probably this model is not going to identify everything because it's a light model, but we can go in different ways or in different directions. So for example, we can say like, hey, I want to use this pre-trained model and I want to add more layers to it. I want to continue training that, and I want to transfer more learning to that. Or we can say like, hey, I'm going to upload my data set and I'm going to teach my model by myself. So as many of you probably may know, I'm a fan of Angular. So I made my example in Angular, but it's not tied to that. You can do it with Vue, you can do it with React, you can do it with plain JavaScript. So for example, here we are going to start just importing our library from TensorFlow models, and in specific, we are going to start just working with Cocoa SSD. We have to import also TensorFlow JavaScript core. Then, as we already talked before, we are going to load our model. Once our model is loaded, we're going to start just calling our webcam. Once we have the webcam, we are going to pass that, and we are going to transform that in pixels for TensorFlow to start just comparing those pixels and those data set to the previous one that we already have loaded there. Then we're going to get all that batch of images. We're going to put that in floats, and then we're going to start just doing the comparison between them. At the very last, we are going to start just reading the predictions that these batch images are going to return us. So we're going to start just detecting everything that we are sending, and then we're going to start just returning all the predictions that we have. So do you want to see the live? Do you have any questions up to here? Okay, I will assume is a none. Let me just close my presentation. And let's run our project here. So right now is loading the model and also is starting the webcam. The webcam. So as you see, it's recognizing that there's a person. And if I put another object there, probably it's going to start just recognizing that. So we have this example. I will share the code with you so we can go through. ¿El suelo?
¿El suelo? Se acá aquí.
So as you see, we can say that there's a TV, there's a book, there's a person as well, there's a chair. The blocks there are just not in the correct place because that is something that you have to start just playing around. The predictions are going to return you the X and Y position. So you have to do some maths there just to try to put them in the correct place. So we have this example Esri. And that code is going to be here. Let me know if you can see my code there.
No.
Okay, let me switch. Here. Okay, you can see it now?
Yes.
Okay, awesome. So we're going to start. As you may see, I don't have anything special here. It's just an Angular project. What I have here is that I added, you have to add each one of the models that you want to use. In this example, we are going to be using Cocoa SSD. We're going to be using PauseNet. PauseNet is a model that is going to start just tracking all your joins and is going to tell you which kind of poses are you doing. What else we have here? Well, this is a HTML that we are going to be using. There's nothing really complicated there. Oh. Give me a second. So I'm showing you the old code that I have. I just update this into Angular 9. So there's not too much difference. Okay, this is what you have to be looking. We're adding here the video. We're hiding this because we're going to replace this video with a canvas. So in that way, we can start just drawing on the top of that canvas. If we do it with the video, we're not going to be able to draw in front of the video. So that's the reason we're hiding it. Then we just have the ID of the video so we can get it, and we have the ID of the canvas. So we can start just manipulating those two HTML elements. Here's where the fun starts. So first we are going to add the training model that we want to use. In this case, is Cocoa SD. Then after that, we're going to get track or to keep track of the HTML video forever, whenever it starts or when it ends. We want to know that, and also we want to get all the data that we're going to be loading. In fact, we want that data just to start just sending that data to our model and just start just getting the predictions. The first thing we want to do is just to get our webcam initialize. So for doing that, we have this example here. We're going to get the HTML element that we want to manipulate. Then we're going to say like, hey, we want to use the media device. In this type, we're using the facing mode as user because let's imagine that we are using a mobile phone. We're going to be using the front camera. If you want to use the back camera, then you will have to do something like rare. That's pretty much all. You can initialize this with the audio of true. In this case, we don't need the audio, so that was the reason I just put that as false. And then we're going to assign the source object as the stream that we're just receiving. And once this starts and this is loaded, we're going to start the camera. This is going to be the play. That's pretty much all this function. So after that, we have to load our model. And for doing that, we're going to call our predict with model. Our predict with model is going to start just loading our model. And once the model is loaded, then we're going to detect the frame. We're going to pass the video, all the images that we're getting from there, and we're going to pass the model. The model is going to be like from where it's getting the source, the data source, and all of that. So after we get that, we're going to just detect every image that we're sending from the video, and we're going to get the predictions. Then after getting the predictions, we are going to start just rendering those predictions. This rendering predictions is where we are going to start just drawing inside the canvas all the boxes that you saw, all the texts that we're getting from those predictions. So first we're going to get the canvas, then we're going to get the context of the canvas as a 2D. we're going to give the weight and the height for that canvas. We want to start with a clear canvas. We're going to put obviously which kind of font and the size of the font that we are going to be using. We're going to apply that to the context. Then we're going to say where we want that that to be. We want it to be on the top, and we're going to draw the rectangle there. I put this ID because I wanted to paint in one color one thing and in another color another thing. The reason was because I want to identify between one image to another. Well, this can be just removed and it will work as well. So this was what I was talking about. When we get these predictions, we are going to get all the information of the things that we are watching there. So for example, if I would put a console log here, and I just put, show me everything that you're getting from this prediction JSON, and we load it again. Give a second. So my server is starting. Just remember that with Angular, you have to run an ng-serve, and this is going to start your local server. Is going to open you a browser tab with your application running there, and then you can start just doing debugging there. Okay, we started. The camera is starting there as well. Okay, we have it here. So if you see, we start just getting all the predictions that we want there. Every prediction has a score. The score is going to tell you how accurate is that from the data set that they are comparing with. So let me stop this. Okay. We will open one of these ones. Here in the box, as we mentioned, we have the X, the Y, and we have the height and the weight for it. This is going to help us to build that, that box that we are watching there. And then the class is going to be which kind of object or which object you're watching. And then the score is going to be how accurate this is. So for example, in this occasion, I was opening my camera, just watching me. And then it says that it was a person and the accuracy was like .8. So it was pretty accurate from there. So once we saw that, we already know from where we're getting these options. This is why the box was like the face from the actual body. The reason was because I added 210 and 70, so it replaced it to another thing. The reason why I add this is because if you are too near from the camera, if you are in a short distance, then this object is going to be like moving the box. If you are like kind of far, then it's going to be also moving. So you have to start just doing a kind of math there, just to try to make the box be with the object. So also you can draw the line, which color you want to apply there. Then you just start adding the rectangular to that. And that's pretty much all here. You add the font and all of that. And then you have this one, which is going to be adding all the text that you want. If you see, we're adding the text, the prediction class. The prediction class, remember that it was person in this example, and that's pretty much all. So as you see, doing prediction of images is pretty easy. There's not too much code involved there, but you will have to know when you want to apply it and where you want to apply it. So as I mentioned, we already have also MobileNet. We have Cocoa SD. There's a resource that I have here. Let me share it to you. Yeah, here is it. So all the images models that we have is the MobileNet, we have PauseNet, we have Cocoa SD, we have BodyPix, and we have DeepLab. All these ones are going to be oriented to or focused to images. Then we have the audio. This audio is for audio recognition. So this is going to transform the audio to text probably. This is going to transform the audio just to try to catch anything that you don't want. So probably you have an audio that has a lot of bad words and you just want to blink those bad words. With this, you can do it. Also, you have text. So if you're lazy like me, you can build your own application just to start just like typing at the moment that you are talking. And then you have another one that is general utilities. These general utilities can help you just to predict like some patterns. So like, for example, in this COVID stuff, you can start just getting all the information that you're getting from, let's say, from a data source such as Johns Hopkins, and you can start just running predictions just to see how much are they going to increase their cases, or how much are they going to decrease their cases with some features that you already know. Like which features? Probably the ages, probably, I don't know, the health of the people, probably the areas, I don't know, a lot of things like that. So I guess that all of you want to see another example, a little more complex. Am I right, or do you already got bored?
I want to see a demo.
Okay, well, you're speaking for everybody, right? Okay.
I think everyone's tired.
Yeah, I know that. I'm tired too. Okay. So in this scenario, we're going to start just talking with playing with PauseNet. I already have this example here for you. So for this one, we don't need this, and we're going to uncomment this one. So what we're going to be doing here, this example is going to take each one of the frames that we are capturing through our video cam, and it's going to start just analyzing each one of the frames compared with the vectors of your body. The vectors of your body are going to be composed on each one of the joints of your body. Let's say that, for example, for one of your arms, is going to take from the beginning of your arm till the end of your arm, where you have the joints. So for this example, I will need my assistant, which went outside to play, I guess. Meanwhile, she's here. Let's start just having this. Okay, you have it here. If you see, she's doing like some poses there, and her face is obviously blocked by this Angular stuff. She's saying hi. So each one of the frames that we are capturing there is transformed in these joints, and then it's transforming in this linear stuff. So in that way, we can start just analyzing each one of the movements. If you want to apply this to something, then you can do it, for example, for sports. I love soccer, so when I go and play soccer, I want to improve my skills. How can I do that? I can start just studying all the poses that I do whenever I'm going to kick a ball, for example. Probably I'm too near from the ball. I hit the ball with the wrong side. I don't know, probably I'm doing a pause with my arms that makes that the ball goes too much to the top. So this is pretty cool. This is giving you a lot of data. Okay, thank you very much. And let me show you how you can do that. Let's place this here because we are going to use it later. And let's continue with the code. Okay. As I already mentioned you, this is taking frames. So for taking frames, we want to do an array of those frames. In that way, we can emulate the movement or a video, continuous images there. So what we did here is that now we add an even listener just to know when the video is already there and it has data. Then after it has data, then we create this action, which is going to be a service there. And this service is going to have this model which is going to be the PauseNet. The PauseNet is going to be using a method that is called also PauseNet. And then this is going to do just a defer, just to start just getting all the images that we get there. Each one of the images are going to be passed into this method that is called estimate manipulation process. This is going to be pretty similar to the one that we have for doing the predictions in the Cocoa SD. So remember that after we do something with an observable, we have to do a pipe. The pipe is going to be the line of the pipeline of events that we have after each one of subscriptions or observables that we do there. So what we are doing with each one of the things that this is returning to us. We're going to observe this as an animation frame scheduler. Then we're going to get all the predictions that it's going to give us, and then we're going to render those predictions, which is an array, up to here. And then we're going to take that until a timer that is going to be 1000, and after that, we are going to repeat that. As you see, this is just a pipeline that we want to follow until the end of our program. Then, once we get that, we are going to have a sub here. Sub is another library that is going to allow us to start just adding some, how to say it, some resources that we already have there, some pre-training models into one array, let's say in that way. That's the subscription that we are having here. Then we're going to start just concatenating that map with the actions of each one of the models, and that's pretty much all. So this is what we are going to start just doing. We go here. Here we're passing just an array. This array is going to tell us what do we have here. So here we have ages, we have knees, we have arms, we have a lot of things that we can identify there. Let me show it to you. Okay, here we have it. So for example, we have, oops, going too fast, wait. Let me kill the process. Okay, reprint. Let me grab that again. And this time, we're going to add a debugger here. Okay, we have our debugger here. Then we will be able to see what was K. As I mentioned, K is an array of objects. Then the score is how accurate it is. And then we have the key points. The key points are going to be each one of the joints that we have or the parts of the body, if you want to tell it in that way. As you see, we have the nose. The nose is going to tell you in which position is your nose, according to the frame that we are analyzing. Then we have the same with the left eye and with all our body parts here. So if you see, it's really powerful. We can do a lot of things with this stuff. Actually, I love to play with all this. So let's say that, for example, you want to build something just focusing in your eyes. What do you want? What do you have to do here? You will have to implement a map there just to say like, hey, just give me all the maps, sorry, all the eyes from this array. In this scenario, I didn't want to do that, so I'm just playing with this stuff. I just want to put an Angular kit on the top, and that was it. So once that we already know what is K, we do the same. We draw our canvas, we get the context of our canvas, we set the height and the width of our canvas, we clear the rectangle, and then we draw it again. Then we have the confidence, which is going to say like, hey, just give me whatever you have with more that you have more confidence that it is real. Then we have our score. Our score is going to let us know if this is accurate or not. And then we have our key points. Our key points, if you remember, are each one of the parts of the body that we have. So we're going to start just doing the draw point, the draw of the points. Just remember that the points are going to be those points that are going to join the lines between the joints that we have. So that was just a little logic that I thought it was going to be cool. So for that, we are just going to loop through those key points that we have. We can do it in this way, or we can do it, for example, as a for each. Then we're going to pass a right, which is the key points. And then the element, which is going to be what we're returning, which is going to be the key point. And then we will have to apply whatever we want to this key point. So this is just another way to do it, but I think you already know this. Then we're going to have our key point. Our key point is going to get from this array that we have, the position that we are sending here, pretty much forward. Then if the score is less than this confidence that we set up here, then it's going to continue. If not, then it's going to return us something else. So here we're going to draw the point. We just pass the context. We just pass also the y. We put the scale there, the x, and we say in which color we want to draw that. Pretty much similar to here. What else? Then we have to draw also the skeleton. The skeleton is going to be joining everything there. So for that, we have this. We have also to adjust the points, as I already told you. We have the mean conference, and then we are doing a for each, as I told you there before, which is going to give us a key point of each one. Then we draw each one of the segments, which is here. This one is going to give us the lines that we saw. And then this is going to give us this into a tuple that we have there, and that is going to do all the magic that we have. Probably some of you are just like asking where is the head or how we did that. This is pretty much this is where we are loading the heads of our little body. So I don't know if you have any question there up to there. You can type it there. I will read it. So if you have any question up to there, I will stop. If not, I will just continue. Okay, it seems not. So that's good. Or I don't know, probably you just got bored. So this is another thing that we can do. As I mentioned, there are a lot of multiple exercises here that you can just play with. This is the PauseNet instructions that we did. There's a couple of demos. This is what we were doing. Instead of having these guys here, I decided just to put an image of Angular. You can just change it to whatever you want. You can go through the documentation. It's going to be pretty much similar to what I say. They load the model, then they use I don't know, a multiplier. They can do a lot of things there. And I think they have also their own demo, which we can see probably. Oh yeah, their demo is not updated, so you cannot play with it. There's this body pics, which is going to show us everything that we have. Why is not supporting it? Okay. Oh, I think I know why. Okay, this is pretty much similar to the one that I did. So it's going to get the joints, and also getting the joints is going to draw from the joints that we have is going to draw the body. In this way, we can have a better shape of whatever we want to have from there. So you can accomplish the same exercise with the PauseNet example that I'm going to share you. Which one else do we have? Okay, let's try this one more time. This seems to be like taking another camera. I don't know why. But yep, there are all examples that you can play around. So I think that's pretty much all. We took like 35 minutes. Again, if you have any question, just let me know. If you want to play with the code, you can go through my GitHub. You can go through my repos. Oops, this is not. You can have this one. You see it was just pushed like a couple of hours ago. I just did the exercise a couple of hours ago because I have to upgrade this into Angular 9 just for fun. So you will find everything here. If you want to get track of the files that you must have, those are going to be inside here. Everything is going to be, all the logic is going to be inside the app component HTML. For this HTML, app component TS. The app component HTML, you can remove everything except this video and canvas that I have up here. Where is it? Here. So those are the only ones that you don't have to remove. Otherwise, it's not going to grab anything or it's not going to paint anything. If you change the ID, just make sure that you change the ID as well in the component TS. And that's pretty much all. For switching the TensorFlow exercises that I have here, all you have to do is comment which one of the models you want to be using. So for these models that we have here, you can use this method, just passing the video and the model. For the PauseNet, as it is taking each one of the frames and it's a little different and it's going to be building an observable, then you can uncomment this and just comment all this block here. And then you can just play and you can just share this to whatever you want, or probably you can get a job from here. Also, if you want to have another kind of cool exercises, there are some templates that I put here. This is an Angular template, which is going to be role-based, and this is a node authentication template that I just put here. This comes with a malware, just with an OAuth token. You don't have to build it by yourself. You just can clone this repo, and you can start just working your authenticated node APIs. You can do the same. You can just put or add your roots here, and that will be pretty much all. So that's all from my side.
That's actually really cool. Anyone have any questions?
Do we have somebody out there?
There's somebody out there. I think we muted everyone.
Yeah, let's unmute everyone and let's have a party here. Oh, something really important is that now you can get certified with TensorFlow. I forgot that. This is something new. This is something really cool. Now you can get certified. This just came up like a month ago. And since we are in this quarantine, I think it's a really cool way to spend some time, learn something cool, something new, and get certified by Google.
I wonder if I unmute everyone. Will it force unmute?
I think we can do it, and then if there's a mess, we can mute them again.
Okay, they're all unmuted. Cool.
we get asked the question if we're okay with it.
Oh, okay, cool.
They're like, they're about to unmute you. Are you okay with that?
Awesome.
My microphone sucks.
Cool. Well, I thought this was really cool. I know I've seen some similar technology coming from AWS when we had that talk with Amplify.
Yeah, they have.
Yeah, it's really cool.
Yeah, they have with AWS, they have with ML5, they have also with Google stuff. They have a lot of, I think it's Google Cloud. They have a lot of things coming up there. I saw that TensorFlow was pretty easy just to ramp up, just to start just playing around. They already have pre-trained models. You don't have to do it by yourself. If you go, for example, with Amazon, with Google, or even with, I think Microsoft has its own Azure stuff, you will have to train them. To train a model is not really difficult. All you have to do is just to upload a data set of a data set. So let's say that, for example, you want to do a no Willy app, let's say in that way, you will have to upload a lot of Willy pictures there, and then your application is going to be smart enough just to block those pictures in the future.
Cool. Well, if there are no questions, I think we can call this a meeting. I started recording, so I'll make sure that the recording is distributed and posted somewhere for everyone as well.
Oh, pretty cool.
Awesome. Okay. So just everyone knows.
Johan?
Yeah, April?
Yeah. So just out of curiosity, like I think maybe, I don't know, one day, it might just be too much to manage, but it'd kind of be fun to just have a, hey, let's all come hang out on Zoom and catch up kind of thing too. Like,
yeah, that'd be awesome. Oh, I like that idea.
Like, I miss y'all and I want to know what the heck's happening. Like, what's going on with you? And the chat's been so slow, and I'm just as guilty as all of y'all for not getting in there, but still, like, yeah.
Yeah, no, I get what you mean. Maybe we can do like a hangout or something.
Yeah.
Yeah, I'll talk to the ops team and then see. Let's schedule it and see if we can get some people to show up.
Cool.
Yeah,
cool.
It would be nice.
Well, thank you, everyone.
With that said, thanks, Ixshel. That was really, really cool.
Thank you.
A Netflix party and watch the Matrix trilogy.
Oh my god. Oh, what?
I think Lord of the Rings is still there. I'm not sure if you took it out this month.
John Wick.
Dude, that's really cool.
Are you looking at Sandbox?
Yeah, playing Street Fighter with us. That's cool.
Yeah, so if many of you want to know somewhere you can apply this can be applied in games. So instead of using the controllers, like for example with the Xbox or Nintendo or whatever you have, you can use your body as a controller. It's better even than the Kinect stuff. So you can do really cool stuff with this. And if you don't have enough money just to buy a VR game, you can play it from your computer with your body, and it's going to act exactly like in the VR.
That's really cool.
I just like the fact that my college daughter who's interested in machine learning, but is convinced that she does not want to at all learn JavaScript, that I get to say, well, you know.
Oh, no.
You know.
Yeah. Probably I won't choose JavaScript to do something really complex in machine learning.
Oh, that's true.
Probably I would choose probably going with R or with Python.
Yeah.
But if you want to do something simple, something that is going to be running in the browser, or you want them to be running in a lot of multiple browsers, then JavaScript is good. And you can prototype that in just an hour or 2 hours.
Oh, that's cool.
Awesome. Any other questions?
Do you want any other game?
Cool. Yeah, I'm trying to get a hang of Zoom, but it's interesting. I thought I needed to make you a host to get you to present, but it seems it's more for like allowing me to record and stuff. So it's interesting.
Oh yeah, I've never been a host at work, but I've shared my screen as part of a presentation, so I'm assuming it would do the same thing.
Cool. Well, I want to thank everyone for coming. I just want you to know that as soon as I click end meeting, everyone's gonna get kicked.
You're gonna be out.
So
Thank you.
thank you.
All right, bye.
Bye.